Hello viewers, my name is Kyle Lane. Welcome to my grade 12 math CCT. This video will be going over how to graph a reciprocal function based on the graph of the original function. Question 14 on page 257 asks us to write a concise explanation of the steps needed to graph a reciprocal function using the graph of the original function. Use an example and explain the reason for each step. This question comes from Unit 5, Lesson 1, as we are learning how to graph reciprocal functions. Looking at this question again, the key points are that we are graphing a reciprocal function using the graph of the original function. We now know that there will be two functions after we are done graphing, the original and the reciprocal. There are 6 steps that we will take to graph our reciprocal function. First, you must locate the vertical asymptotes. Second, you determine horizontal asymptotes. Third, you determine the coordinates for the reciprocal function. Fourth, you draw the reciprocal function. Fifth, you check if the function is accurate. And lastly, you state the domain and range. We will begin with an absolute function. We can determine the vertical asymptotes by seeing where the original function crosses the x-axis, or where y equals 0. The zeros for this function are at x equals 1, because that's where the original function crosses the x-axis, and x equals 5. Therefore, the vertical asymptotes for our reciprocal function will be at x equals 5 and x equals 1. I've graphed the vertical asymptotes at x equals 1 and x equals 5. These asymptotes also serve as restrictions for our reciprocal function, as x cannot equal 1 and x cannot equal 5. Now we must determine the horizontal asymptote. You must look at the degree of the numerator and the denominator. If the degree of the numerator is lower than the denominator, then your horizontal asymptote is y equals 0. If the degree of the numerator is the same as the denominator, then your horizontal asymptote is y equals a numerator over a denominator. A represents the coefficient in front of the numerator value and the denominator value. If the degree of your numerator is higher than the degree of your denominator, then your horizontal asymptote is y equals mx plus b. You must use the factor theorem to solve for the quotient. The quotient would then become your horizontal asymptote. When we are looking at our reciprocal function, g of x, we can tell that the numerator has a lower degree than the denominator. Therefore, our horizontal asymptote is y equals 0. Since we have determined that our horizontal asymptote is at y equals 0, we can now apply it to our graph. In this case, the horizontal asymptote is the x-axis. We now have our vertical asymptotes of x equals 1 and x equals 5, along with our horizontal asymptote of y equals 0. Now we must determine our points of intersection for our graph. We know that our reciprocal function, g of x, is equal to 1 over our original function, f of x. So when f of x is equal to 1, we know that g of x is also equal to 1. When f of x is equal to negative 1, we know that g of x is also equal to negative 1. Therefore, the points where y equals 1 or y equals negative 1 intersect with the graph f of x, our original function, will also be points on g of x, our reciprocal function. Now going back to the graph, we will follow y equals 1 across to see where it intersects with the original function, because as we just learned, these will also be points on the reciprocal function. Intersections will occur at x equals 6 and x equals 0. We will do the same with y equals negative 1. Intersections will occur at x equals 4 and x equals 2. Another point that we must graph is at the vertex of our original function. The vertex of the absolute function is at 3, negative 2. Since our reciprocal function is equal to 1 over the original function, we can determine that at x equals 3, our reciprocal function is 1 over negative 2. So in other words, our reciprocal function is equal to -1/2. Using the same principles we just learned for graphing from the vertex, we can graph a few more points for our reciprocal function to make drawing it in easier for us. We'll start in this quadrant over here. Since we only have 1 point, we want to add 1 more. Here we know that the original function has a y value of 2. We know our reciprocal function is 1 over our original function, so our reciprocal function is going to be 1 over 2, or 1/2. The same goes for the right side over here. The original function, when x is equal to 7, has a y value of 2. So we know our reciprocal function is going to have a y value of 1 over 2, or 1/2. We can now begin drawing in our reciprocal function. First, you must remember that the reciprocal function will approach the vertical and horizontal asymptotes, but will never cross them. Using this knowledge, we can now start to connect the dots and draw the function. So we know between these points, the reciprocal function is going to cross both of them. And after it crosses this point, we know it's going to approach the vertical asymptote of x equals 1, but it will never cross it. And we know when it comes to this point, it's going to approach the horizontal asymptote of y equals 0, but never cross it. So using that knowledge, we can start filling in our reciprocal function. The same method can be used on the right side of our graph. We know the reciprocal function is going to pass through both of these points. And as it gets closer to the vertical asymptote of 5, it's going to approach it, but never cross or touch it. We also know that as it gets closer to the horizontal asymptote of y equals 0, it's going to approach it, but never touch it. Now we will graph the bottom of our reciprocal function. The reciprocal function will pass through all of these points, and as it approaches the vertical asymptote of 5, it will get close, but never touch. And the same thing goes for the other side. As it approaches the vertical asymptote of 1, it'll get close, but never touch or cross. So using that knowledge, we can fill in the rest of our reciprocal function. And there you have it, the reciprocal function fully graphed. It is important to remember the end behavior of the reciprocal function. The function is continuous, or it never stops. Therefore, you must put arrows where x and y approach infinity, and x and y approach -infinity. Now we must make sure that our reciprocal function is accurate. The first check we have is to make sure that where the original function was positive and where the original function was negative, the reciprocal function is the same. So in the left quadrant here, the original function is positive, and we can tell that our reciprocal function is also positive, or they both stay above y equals 0. The same is true for the right side. The original function is positive, and our reciprocal function is positive. Looking at the middle, we see that the original function was negative, or is always under y equals 0. Therefore, we must make sure that the reciprocal function is also under y equals 0, which it is. We know that our reciprocal function g of x is equal to 1 over our original function f of x. Therefore, we can take any point along our original function, for example, -2, 3, and put 1 over the y value, and then that should equal a point on our reciprocal function. So this is the next check we're going to do. So we have -2, 3 on our original function, and we put 1 over the y value, so it would be -2, 1 over 3 for our reciprocal function. -2, 1 over 3, check. You can do this for any point along the original function to make sure that the reciprocal function is right. So for example, we can go here at 5.5 and 1/2, and then the reciprocal function should be 5.5, 1 over 1/2, which equals 2. So the reciprocal function should be 5.5, 2, which it is, which is another check. Now that we have determined that our reciprocal function is accurate, we must state the domain and range. First, we will do the domain. So looking at the x value, we know that x is continuous towards infinity and negative infinity. We know that x is continuous in approaching the vertical asymptote of 1, both there and there, but it never touches 1. And x is continuous in approaching the vertical asymptote of 5, there and there, but it never touches 5. Therefore, we know that x is any real number, except that x cannot equal 1, and that x cannot equal 5. That is why our domain is x such that x is the member of the reals, and x cannot equal 1, and x cannot equal 5. When looking at the range, we must look at the y values. We know there is a horizontal asymptote at y equals 0, and above the horizontal asymptote, the reciprocal function will approach it, but never touch it, and the reciprocal function will also approach infinity. Below the horizontal asymptote, we can see that the y values actually only start at negative 1/2, and then they approach negative infinity after that. So we can conclude that our range will be y such that y is a member of the reals, y is greater than 0 because above that asymptote it approaches it but never touches it, then it goes to infinity, and y is less than or equal to negative 1/2 because it starts at negative 1/2, so it's equal to it, or less than because after that it approaches negative infinity.
One career that uses the idea of reciprocal functions is archaeology. Since logarithms are the inverse of exponential functions, any career that uses logarithms is using the idea of inverse functions and could need to know how to graph them. Logarithms are used extensively in archaeology. They use logarithms based on the carbon content to determine how old bones are.